So thank you for coming to our session instead of rushing straight to lunch. So today we're going to talk about how the team at NIB Group has governed dozens of DBT projects and environments over 5 years and counting. This is our agenda, so we're going to have a bit of a chat about our team, our data governance problem, how did this happen, the solutions that we did with tagging and automation, the learnings that we had along the way so you don't need to make the same challenges, mistakes, opportunities that we did, the business impact, and then what's next. So some intros. So I'm Pip Sidaway, a data product manager at NIB. I've been there nearly 16 years now. So I've been through a whole lot of different roles. I was an analytics engineer before this role, so very much aligned into the DBT community.
And hi, I'm Juliana. I am a lead data engineer at NIB. I've been there for about 3 years. And I'm essentially a chapter lead of the data engineering capability.
Yeah, so a little bit about NIB. So we provide health and medical insurance to over 1.5 million Australian and New Zealand residents. We also provide health insurance to over 180,000 international students and workers in Australia. And we are the third largest travel insurer in Australia and a global distributor of travel insurance as well. So our team is made up of squads. So we have different business lines in our company, and so we've sort of got 4 different squads aligned to that. And then we've got the cross-functional team of the technical business analysts and data engineers, data warehouse engineers, and analytical engineers. So today, me and Jules are going to be your librarians. So has anyone seen this show? Yes? It's an old show, but it is worth watching. It's really fun. So the librarians are specifically chosen for their skill sets, so it's not an ordinary library that they look after. So we're going to take you on a journey using the library as a bit of a metaphor for the process of data and tagging. So the books are our data tables, essentially. The library is full of lots of magical objects. There's security issues, hidden rooms, there's no labels on anything, and nothing's classified. Lads, is it even a library? So I found this book. So this is a book about Australia. So in case you can't tell, we're from Australia. The accents probably give it away. So we've got the population, looks pretty legit. We've got a map, Australia's way down the bottom. Took a long time to get here. We've got the flag, a few animals that you might find in Australia, and of course the drop bears. So I suggest Googling that one. There's a lot of information on that there. People always think Australia is smaller than it is, so this is a bit of a comparison map showing how big it is. We certainly don't have the population, but it does take a while to drive from one side to the other. And of course I have to mention Bluey. So everyone here, hopefully, if you've got kids, you know Bluey. So Bluey lives in Brisbane, which is in Australia, and so if you want to hear more of the fun accents and slang, go and check that out. So our business problems. So we've been playing with DBT since around 2020. So we've been part of the journey through the Fishtown analytics, and I remember having to change from Fishtown to DBT Labs. That was fun. And so we had some consultants in the early days, so shout out to Lauren, who's here as well, and Christine, who helped us. So we went through the debate of one project or many. So as you can see, we decided many. So we've got 48 DBT projects. So we had some challenges at the start with just having one, and that's a whole different talk, so I'll park that one for now, but I'm happy to chat to anyone about it. So we went with multiple projects, so that comes with its challenges as well. So how do we keep all the versions aligned? And how do we keep track of all these models that are in all these projects? How do we classify all our data in there? And where is the PII data? So we've got 15,000 models. And 60 DBT users. So it's quite a big ecosystem to keep track of. We also still have a legacy environment, which is like the big black box where things happen and nobody knows what goes on in there. So data democratization, this is what we want to get to. So these are all the questions that the data team are often asked. How do I find the data set? What is the source? And how is this number calculated? So we're often to be able to answer these questions, you need someone who can actually dig into the systems to find this out. And my favourite was always the mystery calculations, and you always get something that somebody's times it by 1.1 and you're just like, why? There's no notes or anything in there. So we want to make this data easy for users to find, so available, searchable, and governed as well. So we want this, and not everybody can find out these things because it's in our hidden black box. So data quality and trust. So can we trust it? Do we know when this data was last updated and what tests were run on it? How much data is in there? Is it months, days, years? And back to the book analogy. If I pull out a book / data set, is it fiction or non-fiction? Well, we don't know because it's just a book with no label. So how did this happen? So it's always been a problem. So in the old system, you get your very linear processes where things have to run one at a time and it will take a whole day to get yesterday's data. And there's hidden calculations in there too. So we went through a migration, as a lot of people do, moving from your on-prem tools into the cloud. So we had this opportunity now that we're all in the cloud. And so the good news is that we're very close to shutting down our legacy system. We've got about a 6-month plan where we're going to do the switch, and I'm very excited about starting to turn things off in that world. The next good news is that we're actually off all on-prem software. So our company doesn't have a data store anymore. So everything is in the cloud, it's just our legacy stuff is running in the cloud. Kind of counts, right? So basically, we've moved libraries. So we've moved from the one bit messy everywhere into this fancy new one, but we still don't really know what's in there. So this is our data stack. So we always got to have the data stack slide. I know when I talk to people, I love to know what tools everyone's using. So we have our data producers. So we've got our structured data, we've got various applications, and we've got our unstructured data. We have multiple tools that we use for ingestion, and that mostly depends on how the data is being delivered to us. We use DBT Core, so we're transforming as our transformation tool into raw data through the transformation into our MART. And Snowflake is our data platform. And we've got various other tools. We've got our security covered by Snowflake and Immuta, and some of our orchestration using BuildKite and EventBridge. And part of our discovery and catalog, so we've got Select Star, which is our data discovery tool, and we use Tableau as our main sort of reporting to the business tool. And we've got some data science ML teams using SageMaker as well. So just to reframe the problem. So currently in this old library world, we needed the data expert. We didn't have data visibility. The quality and trust wasn't there because nobody knew what was happening. And the data classification, we didn't have that. And then we've got regulatory requirements as well, so knowing how old your data is and what type of data is being stored. So to solve the problem, there's a few different levers to pull. So you can throw people at it, process and automation, and technology and tooling. So we did a little bit of all of these. So we selected a tool, Select Star. So this was for facilitating our data discovery. So now that we had all our data in one place, it was going to be easier to just surface that up. This is an example of our date dimension. And so you can see that we've got the business owner and technical owner. You can see the table size, when it was last refreshed, and a description of it as well. And the advantage of this is we can actually see within this tool, we've got all of our data right from DBT through to Tableau as well. So we can see that lineage. We've got data definitions. So within here, we can see what that field actually means. And the amount of times we used to get questions about, but what does it actually mean? Like the date. There's no context really. I mean, it's a good definition here. But yeah, actually defining what those are, especially in like bigger calculations like premium or discount, those types of things. And this is an example of the data lineage. So one of the things we were really looking for was column lineage, so that we could track through to the columns of where they've come through. And so you can see there it tells you whether it was as is or whether it's aggregated, and you also see if it's transformed as well. So I'm going to hand over to Jules to continue the story.
Thanks, Pip. So as Pip mentioned, we now had a centralized location where we had sort of visibility over our different data that was surfacing, and a way that all different data users were able to see the data that was in Snowflake. Some of it was being surfaced by DBT, some of it from other legacy tooling that we were using. However, we still had a significant problem, which was that we needed to actually populate the metadata into our system across all of these, hundreds of thousands of different views and tables that we were using in order to actually make our tools useful to us. So adding things like tags, descriptions, teams, ownership, and quality indicators was going to be the key in making sure that we were getting good value out of our data platform and our governance tooling. So most of you will be familiar with something called the Dewey Decimal System. It's probably the most popular system for classifying library publications in the world. It's a up to 6-digit number, which is typically punctuated by a dot point, and it describes the category and the subcategory of a given publication. What you might not be familiar with is the Dewey Editorial Office, where 4 full-time classification specialists and then a support team of catalogers actually assign the number for every single one of these publications. Now, they've recently introduced tooling in order to partially automate this process, but that was definitely far above and beyond the sort of resourcing that we had internally. Our goal when we were introducing our system was that we needed it to be scalable, we needed it to be at least partially automated, ideally completely automated, but still waiting for AI to solve that problem. And we needed as much consistency as possible between all of our different tools and vendors that we were using, because having different siloed metadata between your tools is still a significant problem in a lot of the sort of dbt cloud and setups that we're still working with at the moment. So one key difference between library publications and data tables is that library publications are typically independent. One book has little to no relevance to the book next to it on the shelf. However, with your data tables, you're going to see a significant correlation between the source tables and also the various downstreams. So we actually reasoned that if we had or could get our hands on sufficiently robust, essentially column level lineage, we could potentially leverage that to propagate metadata from their source systems all the way down to the various reporting and data science and ML layers as well, without doing ideally too much work. Now, as you probably know, that is a gargantuan vision, and we decided to start with a little bit of a smaller challenge, which was to start with our security tagging. So we wanted to just propagate security tags and classifications through our lineage, and figured that if we did that, then we would vastly improve our security posture and also lay the groundwork for propagating other types of metadata going forward. So we started by introducing different classifications for our data. So we are, as Pip mentioned, a health insurer and a travel insurer, and we are subject to a large number of regulations, not only in Australia, but also globally. And we had already established our 4 different levels of data classifications. So at the top level, we have the restricted, the confidential, and the internal, and then the public categories. But our next task was actually to break these down into sort of more granular subcategories, which actually match the kind of patterns of data access that we saw from our users. For example, the kind of person who is going to be using or needing access to, say, uncontrolled free text fields is going to be quite different from the kind of user who's going to be needing to access like health insurance claims, say, or maybe like somebody's contact details. And the kind of person who's going to be accessing unclassified raw data, which would typically be a data engineer like me, is not going to need to access somebody's PII health data. So what we wanted to do was introduce these data classifications and seed them at our sort of source database layer in Snowflake and see if we could get some way of propagating some of that metadata through. So we defined the way that we wanted our tag propagation and automation to work at a really high level. We had kind of 4 criteria that we developed in terms of what we wanted to do with it. The first was that all of our kind of key metadata and all of our tagging should be defined in the dbt schema.yaml as the source of truth. Because dbt is basically the place where all of our different data stakeholders, except for potentially some business users at the end and maybe some very, early on source system users, kind of come together. We wanted that to be the place where we could rely on essentially all of this metadata being accurate and feeding into all of the other systems that we use. The second criteria was that we essentially wanted tag propagation. So in the example that you see here, you can see that there is, and this is a completely fake example, but a contact table where we define a contact ID, which is tagged as pseudo PII. And we expect that to propagate to a downstream model, say contact ID in the correspondence table. The third criteria that we wanted was to be able to establish a tag hierarchy. So some tags are obviously more sensitive than other tags. And in the example that you see here, in the letter body of the correspondence model, we essentially combine the name field, which is PII, and just a weekday from the date model. And one of those is at a higher level of restricted classification than the other. And so we would expect the PII tag to essentially win out. The last criteria, was the ability to manually overwrite these tags at the model at which we were kind of propagating them to. So in the example here, we have that correspondence table with the letter body now tagged as PII. However, we wanted the ability to potentially retag that or overwrite that with a different kind of tag. We have essentially a free text tag because essentially if you give anybody a long enough timeline and a free text field, they will put extremely dodgy personal data in there. So, you might want to overwrite that and make sure that that's classified at a high level of classification. All right, so what did we do next? We threw the world's most exciting party, a data tagging party. My first tip to you is that if you decide to throw such an exhilarating event, and you are in a remote first environment, at least send people like an Uber Eats voucher or something. It took about 20 people. We had volunteers from across the data specialties. We had people from the business unit. We had some business owners, product owners. We had some contractors, and it took probably about 6 weeks. It was only a couple of hours for each person overall, but it did lay the groundwork for us to be able to tag every column in every model in our source databases where all of the raw data was coming in, which was quite a lot of work. So an example of how we would tag inside our schema.yaml is shown up in the example here. So we essentially tag in the style of Montreal Analytics DBT Snowflake utils, where we have it in the meta database tag section, and we would have our data categories sort of defined there. And the reason for doing this is because it meets Snowflake's expectation of sort of key pair tags to work with their internal tagging processes for security. So we tag at 2 different levels. The first one is sort of at the classifications are always at the column level, and then we also have the opportunity to tag at the model level for data domains, which we're still working on. Next, how we got everything sort of working together in our ecosystem from there is that we would then essentially synchronize all of these tags from DBT back into Snowflake with an on-run endhook after the end of every run. And then we use Immuta for our essentially masking processes, where we have attribute-based masking for every single user, depending on what attributes they have against their Immuta user, which will mean that they will see every column masked that they don't have that particular data classification subcategory permission for. And to get that permission, they would need to go through essentially an elevated permissions request process, and then Immuta would immediately remove the masking from that particular category, but none of the others from all of the data sets that they would normally have access to. So from there, SelectStar actually ingests data, ingests some of that metadata from Snowflake, and also we push the DBT manifests into SelectStar to additionally populate some metadata via an API call. SelectStar also provides a cool functionality via their DocSync feature, which allows us to synchronize back some of this metadata to the original DBT repository where we've made the changes. Specifically, at the moment, the descriptions. So in terms of the actual tag propagation and the lineage, we had a few cracks at this, and unfortunately, this is only a partially solved problem at the moment. So one of the essentially issues that we ran into here was that Snowflake, up until recently, we attempted to sort of leverage Snowflake lineage for this propagation, but Snowflake lineage didn't support the propagation through views, only tables, essentially. And so we had quite a lot of view materializations across our data platform, and that is something that they've added functionality for recently, and we're kind of moving ahead, looking at the different ways to increase the amount of tagging that we have across our platform. But we are, at the moment, one of Snowflake's kind of top taggers. How did we kind of do that, considering that, you know, we ran into these limitations with our expectations, I guess? We added a bunch of different custom tools, essentially, that we kind of maintain in-house in order to bridge the gap for the time being. So the first one is dbt CLI, which is essentially just a wrapper around the dbt command line interface. It allows us to specify our kind of special nib conventions around naming, and it helps us to avoid sort of naming clashes. And we're pretty heavy like GitHub users, so we wanted everything to run off branches and all of our tables to kind of reference the branch in the names when we're developing. So that's one of the things it does. One of the other cool features that we recently introduced into this one was actually scaffolding the schema.yaml according to our internal conventions. So we added the ability for it to call Snowflake's system classify function, which essentially looks at the table that you've just created in development and will take a sample of that and actually infer the data classification category, map it back to our internal classifications. The next important tool is what we call Looking Glass, which is a break glass privilege escalation process. So this is something that our CloudOps team had already put together. We just kind of hooked on at the end, where essentially it will, as soon as a small group of approvers gets a ping on a particular data request, which we have sort of our internal UI for, they are able to immediately approve that request for that particular data classification. It will send an API call to Immuta, and then Immuta will immediately add the attribute to the user, which unmasks their query results immediately. The next tool we call dbt tag align, which was pretty key in closing this gap of tagging. And it kind of periodically reviews all of our dbt repositories, and actually, once again, uses the Snowflake system classify function, except with sort of a larger sample size, which can be a little bit expensive, but we still find it, you know, valuable. to raise automatically PRs against all of our DBT repositories where we're finding that a manifest, schema.yaml is either missing or it's not meeting our expectations based on what Snowflake is predicting for each of these column classifications. Lastly, there is also nibdbt utils, which is where we define all of our standardized macros, which we use for these on-run end hooks and all of the tagging, as well as so many other things. And in terms of external sort of tools that we also use, which are really, really important for maintaining that sort of consistency and that visibility, we introduced Backstage, which is, I believe, an open source tool, where we're able to sort of see the DBT repository in the context of all of our other very large sort of GitHub repository environment. So in the example that I have here, we use DBT for part of our data de-identification processes, but they also essentially has an API, which is an AWS API, hooked off on the end of it. And in Backstage, we have all of these so that we can see kind of a lineage of non-reporting systems that you typically wouldn't get as much visibility over in other kinds of tooling. On the consumer side, something that we found really, really useful is SelectStar's ability to essentially automatically recommend the descriptions for different models and then synchronize that back to the DBT repository that it originally came from. It also gives us the ability to potentially choose between multiple different descriptions where it's coming from different places and you're seeing, essentially a few different ones. And lastly, something we also find really useful is our impact reporting, which is also from SelectStar via GitHub Actions, where whenever we're raising a PR to essentially create or change an existing DBT model, we will actually receive in the PR an impact report saying here are the downstream models that are going to be impacted, and here are sort of essentially a link so that you can find the top users of that. Now, in terms of what we learned from this process, the first one was that, I've mentioned that we ran into some difficulties with propagation. My recommendation would be if you're going to embark on a journey like this, then make sure that you're kind of assessing all your different options and you're communicating to your stakeholders what your platform is going to look like at each stage of evolution. So we had an idea that Snowflake was going to be adding this functionality at a certain point in time, but it's really important to make sure that your stakeholders are aware that this is the state now. This is going to be the state in 6 months. This is going to be the state in 2 years or something like that. The next thing that we learned was tagging semantics. This was a really interesting one. So essentially, there are lots of ambiguous cases when you're going to be tagging classifications for different categories, and I would recommend that you establish early on essentially a point of reference, ideally a human, who is going to be able to adjudicate in ambiguous cases. For example, is gender considered to be personally identifiable information? Is yes. Is occupation, going to be also PII? You need somebody who's going to be able to tell users, especially if you have a large group of users who are very diverse, what they should be doing in those ambiguous cases and essentially develop a sort of almost case precedent. So we found that very useful. And the third one, always when you're going to be rolling out sweeping changes to the platform, is going to be change management. So, always communicate any changes to the platform to your lovely stakeholders early on, especially if you're going to be masking columns for the data that they access for their work every day, and if there are any changes to how that process is run at any time. So overall, whilst we had a few challenges while we were doing this process, and it's still an ongoing one, we did significantly increase the metadata coverage across our platform and also the visibility and consistency of all of the metadata and the data inside our magical library. So I'm going to hand back to Pip, who is going to talk a little bit about the business impacts.
Thank you. Right, so we've got this new world now. So we've got tags. So now we can discover the data and we can meet our regulations. We've always focused very heavily on DBT YAML being the source of truth. We had increased data usage, so all of a sudden there was more interest from the business and less questions, but they were really keen and they loved the way that they could interact with the data. There was visibility. You could see the lineage, you could see the source the data came from, you could see the calculations. The data questions, very much self-service now. It's only really sort of very technical ones that we get. So it's sort of stopped all that context switching between things. We also now have data usage information, so we can actually see if our Tableau reports are being looked at or not. And we've got auditable processes, so with break glass and our attributes, we can see who is accessing PII data and when. What's next? Excuse me. This is my favourite slide. So being a data product manager, my dream state is getting this data product dashboard. So being able to see who is using it. Is it still being used? Is it fit for purpose? Seeing if there is any PII data in there so you can monitor it. And there's of course the cost to produce the data product. Heading into the future, no talkers, you've always got to mention AI these days. So definitely wanting to utilise the automated tools. So data identification and tagging, as Jules has talked about, and just being able to do a lot more of that sort of heavy work, just automated, and it's just a validation. And so part of we also have certified and validated data. So now people can see the tests that have been run on the data, and we have these certified tags that we can apply so people know that these are quality data products that are being produced. So we've got our brand new library. So we've organised our tagging system and it's easy to find what you need. We've got self-service now available and there's a clear process to get the data, or books in this case. So PII data is well looked at and there's auditable processes, but if you do need access to that, it's a really simple process and there's not a lot of time from asking for access to getting approved. So thank you very much for coming to listen to our talk today instead of lunch. And if you've got any questions, we're happy to chat to you afterwards or in the lunchroom, or else there is a microphone that can be run around as well.